A thing that you will need to find out very often is the factors of a number in an Olympiad. Factors and multiples. First, we'll look at factors and how to find those factors. Okay. There are two ways that you can find them: prime factorization and factor trees. Both of them help you find the prime factors, and you can multiply and mix and match them to find the factors. So we'll take 600 as our example for both prime factorization and factor trees. Okay, so let's take prime factorization first. You will write the number that you are trying to find the factors of. I'll take 600 in this example, and then you will make a table in this form. Find the smallest prime that can divide 600. We know by the divisibility rules that 0 is even, and then 2 can divide this, which makes it 300. If 300 is also divisible by 2 because it ends in 0, so another 2, right? And then what do we get? We get 150. Again, ends with 0, so it's divisible by 2. Then we get 75. Now we have to find out the next smallest prime is 3, right? Is it divisible by 3? 7 plus 5 is 12. 12 divided by 4 is 3, so it is divisible by 3. So 75 divided by 3, you get 25. 25. Is it divisible by 3? No. The next biggest prime, it is 5. Is it divisible by 5? Yes. So we take 5, and then whatever is left, we get 5 again, right? So the prime factorization for this will be 2 cubed, because that's how many times 2 is coming, into 3 into 5 square, because that's how many times 5 is coming, right? So this is how you would find out the prime factors. Now to find factors more easily, there is the factor tree method. Let's take this example, right? But in this case, factor tree method will only help you in smaller numbers. Okay, so let's take this example. What is the combination that I can think of that when 600 and 600 is multiplied, we get? So I can take one from here also. Right? So I can think of 302, right? 2 is already a prime number, so it can't be broken down further, while this can be broken down. 150 and 2, 75 and 2, 25 and 3, 5 and 5. Now you might be wondering what exactly I have done here. I've separated all of the numbers that aren't prime into numbers further and further and further. I've broken them down, right? And then I've come to a stage where I can't break them down anymore. Now all these numbers that can't be broken down further are my prime factors, and you'll see that they're the same. 2 cubed, there's 1 3 into 3, and there's 2 5s into 5 square. Okay. There's another way that you can do factor tree, and I think that way will take less of your space. Find the ones that are closer to each other, 30 and 20. I know that they can also multiply together to become 600. Okay, this will take less of your space. What can you think that can divide 30? I can think of 5 and 6. 5 is already a prime number, and here I can think of 5 and 4. Okay, then this becomes 2 and 3, and this becomes 2 and 2. Again, the same thing is followed, and we get 2 cubed into 3 into 5 square. Here you can see you can easily find the prime factors of it, and to find the factors, all you have to do is find combinations, right? 2 into 3 becomes 6, 6 and 100 becomes a combination, because whatever is left, 2 square into 5 square becomes 100, right? That's how you find the factors, and factors that are corresponding to each other.